Hey everyone, I hope now you can see me. I want you to chat with me back and forth. Let me know if you can hear me. Let me know if you can see this behind me. This is the lab that we're going to go ahead and do. I need some feedback right at the beginning. Hello everyone. Yes, I'm kind of moving my right arm. It's not in the sling anymore. Has no strength. I can barely pick up a glass of water. But that's I'm starting phase 3 now of my therapy, which just a little thing to throw out there. I can only do it once a week now, but no big deal. Labs will prevail. But at least I got no sling. I look normal. My hands are down. I'm able to move it a little bit, very slow. So my hands are the ones that are going to do. But give me some feedback, please. Give me some feedback and let me know, how are you seeing this back here? Can you see it okay? Can you not see it okay? Can you hear me? I'll open up a router for you. Okay, let's go ahead and do that. Let's open up a router. Work with me, router. Thank you. And I'm just going to type here in the computer. Let's just do a show IP route. Show IPv. Yeah, we're going to do show IP route. Tell me if you can see that. Okay, I tried to increase. Whoops. First, let's see how the lab is looking. Step out of the way there, see if you can see it. The routing table for IPv4. We do have a routing table for IPv6, but we'll explain the lab in a little bit. So please, I need feedback. I need to know if you can see this. If you cannot see it, what is the deal? Okay? Because I want to make sure that we have a nice little lab going on here. Okay? So let me see. Let me take a look if anybody's chatting. Nobody's chatting yet. Okay. Well, all right. So I guess everything, is okay. You guys can see me. I know that. And I think I put it large enough where you can see that. First of all, I'll make an announcement. All right. Before we start getting into the lab, I have a book that's coming out in February. It's still in progress as far as the title and all that. Or sometime in February. It's pretty much going to be everything that you need to know about IP. I don't know if that's going to be the title or not. It's still a work in progress, but it has to deal with everything, and then it's a little extras with the routing protocols, and I went through some hex conversions in there towards the end. Has review questions, has everything. Okay, so but it's going to be through Amazon. Okay, it's going to be through Amazon. The price yet, again, it's a work in progress. I don't know. I don't handle that. Okay, so but be looking for it. All right, it'll be, I'm the author. I'll shoot out everybody in YouTube, everywhere, to let you know what the title will be or the ISBN and all that, so you guys can look for it in Amazon sometime in February. So you can go ahead if you're still having, because the reason I decided to do that book is that is the kryptonite for everyone in IT, period. For some reason, whatever the reason may be, that's their kryptonite. So I decided, you know what? Let me go ahead and make a book on IP using my methods. And one of the methods we're going to be explaining here when we start subnetting in IPv6 fairly quickly. But again, be looking for that book. It should be coming out in February. I'm sure you'll like it. I try to make it as fun as possible. A little not too dry. All right, you know me and my personality. All right. So let me start explaining the lab. Okay. Now I'm going to use the mouse, because I really don't want to go crazy where every time I hit it, it's not, aligned properly or something. So as you can see, so I'm not going to even mess with that, but here we go. All right, so here, let me show you the lab. You can see it. We have two 2811 routers, okay? We have two 2960 switches, or really we have 6 2960 switches, 3 underneath each router, and a total of 4 computers. Now, you guys need to build this lab. Okay, you need to build this lab. I wasn't going to send it to you. You need to be able to do it, right? So you have the crossover cables, straight through cables. We have a serial cable going across, putting the clock rate in the right spot. Remember, all this is just practice towards your CCNA X. Okay. Now, as you can see here, we have an IPv6 address. Okay, and we have a prefix length of 54, and we have an IP4 address as well. Because we're doing a dual stack. We're doing a dual stack lab. Okay, you're going to see how both you can do one on top of the other. This is one of the transition methods that we use. So if you already have an existing IPv4 network, it'll be a lot easier for you to move over to IPv6 and then get rid of the IPv4. With very little downtime. Okay, now with the IPv6, I got it down here. See if I can touch there if it wants to. Yeah, there you go. Okay, this is the actual. Well, let me open it up a little bit more. All right. Again, my right hand is not that accurate as of yet. Okay, let's see. I'm trying. I gotta try and work it. All right, here we go. This is the IPv6 address that you were given. This is your starting point, and you are going to subnet that IP address to allow you to have this subnet up here, okay, and these 4 subnets down here, right? 1, 2, 3, 4, and then 5. We have 1, 2, 3, 4, 5 subnets as well, okay? So how do you do this? Now remember, with IPv6, there's 2 parts. There's the network prefix side, which we have right here. All right, this is your network prefix portion, well, before the double colon, okay? The network prefix portion of the address. And to subnet, you're going to be focused on that last section or field, all right? Those 16 bits. Remember, each section is 16 bits. This 4th section, I call it the 4th position. Well, this 4th section, we'll get into in a bit. This 4th section is what we are allowed to use in order to subnet in IPv6. And you want to do that. All right, you want to go and separate like we have here for different VLANs. Okay, so we are going to go ahead and do that. And they're already giving you a starting point of 51. So what do you do? What is the first step that you do? Well, you're going to take this section. Remember, these are all hex numbers, even though they look like decimals, right? But they're actually hex numbers, and each hex number is 4 bits long. So what do you do? Let me see if I can move this further this way so you guys can see it. Okay, so what are you going to do is each one of these numbers, like this number 2 right here, okay, that number 2 is, I call that the first position. The second number, which is 0, well, the rest are zeros, but the first 0 is the second position, and then you have the 3rd position, and then you have the 4th position. These are just numbers that I decided to give it to them, or names that I decided to give it. All right. So what do? Like in IPv4, we gotta draw a line, right? Well, we're already given a line. So if each one of these is 16 bits, you got 16, 32, 48. Now we have 51, correct? So we're gonna go 49, 50, 51. So that's why you see the first line here. All right, that first line right there, that represents that 51. Okay. Now I needed enough subnets, right? I have 1, 2, 3, 4, and then the 5th one between the routers. So I needed enough subnets to cover for me. So what do I need? From right here, from this 0, I start counting like we normally do when we count for subnets. 2, 4, 8. So I have plenty of subnets to allow me to go ahead and give IP addresses to each one of my devices. Okay, so I draw my line right there, and this is something that we normally do in IPv4. We go from left to right to count for subnets. We draw a line, and then the most important part, this bit value, right, to the left of the line is what? That's your network increment, and that's one of the things that's crucial when we're doing any kind of subnetting, is looking for that particular increment number to see how our network increments. Now our network is incrementing in what position? In the 2nd position, meaning right there. Okay, that's how it's incrementing by. Well, what is this value right here? What is this bit value? Well, remember, this is hex, right? So you got 1, 2, 4. So you're going to start incrementing by 4. Okay, so you take the address that you were given with the new mask, okay, because we had to move 3 bits over to the right, plus 51, that gives us a new mask, or not new mask, that's a wrong terminology, the new prefix length. There is no such thing as a subnet mask, okay, when it comes down to IPv6. It's called a prefix length, okay? So we're going to go ahead and move 3. Now we have a prefix length of 54. So we're going to start with the address given, which is 2000, and then in the second position, we're going to increment by 4. So you got 0 plus 4 is 4, 4 plus 4 is 8, 4 plus 8 is 12. But what is 12 in hex? It's C, right? A is 10, B is 11, C is 12. Therefore, we have C. So the number will be 2C00. We have 4 again. That makes it 16. Well, that goes beyond 15, doesn't it? So what's going to happen is like reaching the maximum value of 255. It resets itself, and then it increments the next value over. The same thing here. We reach the maximum value in a hex number, so we reset this to 0, and that turns into a 3. Okay, so these are enough. This is enough. I could have kept on going if I wanted to. I didn't need to. I have enough subnets to allow me to do what I need to do. So that's one of the first things that I did. I went ahead, got whatever IP address, and just so you know, anytime you look at an IPv6 address that starts with 2001, that's going to be a globally unique address. Global, all right? A global address. Remember, now we have special types of addresses. If they start with an FF, is a multicast. If they start with an FE80, let's say, that's your link local address. So you have different types of address that are going to be, you know, they have their own designations. Yes, now on IPv6, there is no classes of addresses, right? Now you don't have to go crazy. Now in IPv6, there are no classes. But in IPv4, there's still classes. And you still, hey, 90% of the world, 95% of the world is still using IPv4 until we actually move into IPv6 slowly but surely, right? And then we'll be full IPv6, and there'll be no need for transition mechanisms or NAT or anything like that. I mean, it benefits everyone, benefits your network. No more broadcast, right? Auto configuration, which we're not going to do today, by the way. All right, once we do the IPv6, we're not going to use that EUI-64 command. We're actually going to enter these addresses statically. Yes, we are. Okay, so make sure that once you draw your lab, you go ahead and take note of these addresses, put it in Notepad, Word, wherever you want, on a sticky, wherever it is that you want to put them on there, because you're going to be doing a lot of copy pasting back and forth, unless you just like to type and you want to type out the entire thing. Okay, it's completely up to you. But this is how I came up with these addresses, okay? By doing my regular subnetting that I would in IPv4, it's just we need to pay attention now to the position, okay, of where we're incrementing by. And remember, this number, these 4 numbers are represented, each number, by 4 bits because they're hex. And that's where, you know, the confusion may lie. Are you going to see this in your CCNA-X or ICND1 or however it is that you're going to take it? No. You're not going to subnet when you take the CCNA-X. All right? You will configure a routing protocol, maybe. Okay? You will definitely be able to actually identify a valid IPv6 address. Right? We have the double colon rule. Okay? That only can have 1 double colon. Leading zeros can be omitted, okay? You need to have 8 sections, okay? Nothing less. So these are the things that you'll be asked. You'll be asked 64 tunneling, okay? Not that you configure it, but again, what are the transition mechanisms that exist, all right? You have the dual stacking that we are going to do today, okay? So all these different things is what they're asking. And just to throw it out there, just so you know, at least to have it, EUI-64, okay, that you would put this actual address inside the router, and then right after the prefix, because you actually write this, all right, right after that, all you need to do is put EUI-64, and then you hit enter. And what does that do? All right, what that will do is actually create the other side, which is the interface ID, no longer called the host, All right, but you can say, I guess, equivalent, right? The interface ID. It creates it automatically using the MAC address of the router's interface by padding it. That's what they call it, padding it, using a triple FE. Now we can get really deep into this, but we're not going to, and there's no need for it, because you may say, well, Lance, every time I see that EUI64, every time I type that command, I see that the beginning numbers change. That 7th bit, right? It turns into a 2. And why is that? If you go into your readings, you'll see that that 7th bit, there's a reason why it changes, is the UL, okay, unique, I forgot what the abbreviation stands for off the top of my head right now, but it adds it, all right, to let you know if it's it turns into a 2 if it's a global address. So that's the reason for that. But again, that's going way too deep for what you need to do for the CCNA. Just understand that that's what it does. And as you go into your jobs and you start doing all this, and I can tell you right now that not many people are doing IPv6, but hey, if you are, you will be using IPv6 calculators. Okay, a very good one to use. One of the ones that I use to verify, to make sure that I did things correctly, okay, is subnetonline.com. Subnetonline.com. They have an IP, they have a whole bunch of things, but one of the things that they do have is an IPv6 calculator. Just put in the network prefix, put whatever prefix length you need, how many subnets, let it go ahead and calculate your subnets for you, and then you're done. And we know that the actuality of it is that everybody does that. But again, you're taking a certification. Luckily, we don't need to subnet as of yet. Maybe when they go to version 20 of the exam or something like that, they will ask us to do that when people have been more comfortable working with IPv6. Right now, it's just very basic knowledge of IPv6, okay? And that's one of the things I'm going to give out in the book when it comes out in February. Just the things that you need to know, all right? That's going to get you through the certification. It's going to get you, you know, if they ask you an interview question in a job, all right? Yeah, unless the guy that's interviewing you says, well, I don't want him to work here, I'm just going to ask him some random question in a book that's about, you know, this thick, in page 2001 that nobody even knows about. So at that point, I'm sorry, I can't help you there. But for the basics of what you need for your CCNA exam, we'll be there. All right, and what we're going to do today is going to be pretty fun. All right, so make sure you have these subnets down in somewhere, because you're going to be copy pasting these addresses into your router. Okay. All right, so let's go ahead and minimize this. All right, and one of the first things that I like to do, I like to first, and let me turn the mouse this way so maybe I can use this right here. We'll move it this way so you guys can see that. I like to first put in the IP addresses to each one of my PCs. Now you can see this lab is already configured. I'm just going to show you the configurations. In the desktop, under IP configuration, you see we have an IPv4. Okay, we have IPv4 set up. I like to use the first available IP address for my PCs, and then the last available for my gateways. Okay, and you can see here that we have the IPv6 address. You see we have colon colon. You see that's the network prefix, and then I have a 1. That will be for the PC. Now, the maximum value, since we're using here a 250, a CIDR 24, will be a 254. That will be the maximum usable address for this particular network. For this one, it would be F, right? It's a hex number. F would be the maximum that we could use. Now, when you see something like this, that means that from this double colon to that number 1 or to that letter F, what do you have? All zeros. All zeros. And for small networks, you can do this without an issue, not a problem. You don't have to make your life complicated or nothing. This could be just fine the way it's doing it. And you can see I have the mask in there. Okay? So you put in all your IP address. You don't have to put the IPv6 first. If you want to, go ahead. I did that on the second run. But if you want to go ahead and start configuring your IP addresses, you can go ahead, because you can see right here. Let me move this up a little bit. All right. This is going to be VLAN 10. VLAN 10 is 192.168.10.0 with a CIDR 24. That's why you see that particular IP address right there. And then we have the IPv6 address. And if you want to go ahead and put in the information, that's fine. Just make sure that you're going to put a 1 colon colon 1 and then colon colon F. The link local address, since it's there, it's always going to be present. It's always going to be present on any interface, any PC. It's always going to be there. Okay? It's always going to be there. You don't, whether it's DHCP or not. All right? These addresses are now used, all right, for neighbor discovery. All right? They have a lot of things that they're useful for. Okay? But you will always see your link local address there, and you know it's a link local because it starts with an FE80. Okay? All right. So we get our IP addresses. Okay? We get them all in there. And then the next thing that we're going to do, we're going to go ahead and go into our switches. And again, let me move this a little bit this way. All right, so you can see that okay. All right. I don't know if you can see that okay. I need to know, you guys need to let me know if you're seeing this okay. All right, if I need to move it to the other way or move it whichever way you need to see it. All right, and what we do here, let me start typing here, one hand. I've gotten okay with this. The first thing that we need to do is create our VLAN. Okay, and again, you can give it whatever name, but if you want to stay true to the lab that we're doing, we're naming the first VLAN. Okay, VLAN 10, enter, name, faculty, and I assigned it to a range from 1 through, let me see. Okay then. I apologize, bear with me. One hand is not as easy as it seems. Okay. Let me, this thing froze on me or what? Okay. Doesn't want to open up now. You see the PC doesn't want to open. The other PC doesn't want to open. That doesn't want to open. Notepad wants to open, which is fine. But now the PCs don't want to open. Let's go to the core switch. All right, let's go ahead and let's close the packet tracer. And I'm not going to say no because I wouldn't make any changes. And I'm just going to go ahead and open it up again. Okay, and there it is. It went crazy on me. Let me zoom in all the way so you guys can see it. All right. There we go. All right, let me go ahead and open that up a little bit. Do the same command. Show VLAN. All right, and again, what I wanted to show you was the ports that I assigned to. I assigned to a range of ports 1 through 10. Okay, if you can see the ports that I assigned it actually to. Okay, so we ports 1 through 10, and you're going to do that to each and every one. And of course, you must trunk your ports. So you got to trunk this port, and when you get to the core switch, you got to trunk that port, trunk that port, and trunk that port, and that port. So all the switch to switch and switch to router ports must be trunked, like show in trunk, all right, to turn on that 8021Q encapsulation. So that needs to be turned on because only VLAN 1, or the native VLAN, the administrative VLAN, is the only VLAN that can go across access ports. So every other VLAN must go across a trunk port. So you got to make sure that you trunk all these ports right here and this port right here that's leading to the router. Once you create your VLAN, you give your VLAN a name, and you want to do that because if you don't give your VLAN a name, it's going to give you a number for the name, and you don't want that. Okay, so you create your VLAN, you give your VLAN a name, you assign it to the interfaces that you want. And of course, we're talking about these switches down here. Okay, and then then you trunk the ports. In this case, in these two switches, you're going to trunk the ports here and here, and in the core switch, you're going to go ahead and assign trunk the ports here. Some of you may be asking, hey Laz, what about STP? Do we need to be worried about STP? But remember what STP does, the span tree protocol. STP is only for redundancy. There's no redundancy here. There's no looping that could be going on here. You're going to fall into that problem. So you don't have to worry about STP, okay, in this juncture right here. And now if I were to connect this cable, this switch over here to this switch over here, then most definitely you would want to then tweak your span tree protocol. You want to lower bridge priority and set up all this stuff, okay? All right. From there, we're going to go ahead and go to our router, all right? And in our router, let's go ahead and open it up. Let's put it over here so you guys can see it. I hope you can see it. You guys need to give me feedback, okay? And let's just do a show start. Normally in the certification, they make you do a show run. I like to do a show start. If I do enable, that would help. I use a lot of shortcuts. Some students tell me that you can use EN or SH start, but if you type SH and doesn't take it, type the whole show. Okay, show start. Okay, now this command right here. The only reason that I type that command is because we will be doing a routing protocol. We will be configuring RIP version 2 for the IPv4, and then we'll be configuring EIGRP for version 6. So IPv6 forwarding of packets, or routing, if you want to say, is disabled. So in order for you to route an IPv6, you need to type in IPv6 unicast routing. If you're not going to do any routing with IPv6, if you have one router that's connected to all your networks or what have you, and they're directly connected networks, then you don't need to worry about IPv6 unicast routing. Okay? As you can see, since it's a router on a stick, right? Router on a stick, one interface, the F00, okay? Then you have two different VLANs that are coming through there, which is two separate subnets. That means I need to create sub-interfaces. Now, I like to create my sub-interfaces with the same numbers of VLAN. I'm sure everybody else does as well. It's logical, okay? That way when you look at it, you say, oh, okay, I know what that VLAN is, all right? It's not required. It is just a recommendation. It is just a recommendation. The next thing, the encapsulation, .1q, that number that you put there must match. It must match the VLAN that you've created. So if you created VLAN 10, then you must create the encapsulation of .1q. It must be 10. It must match, or else it will not work. All right, will not communicate. And I have both IPv4 and IPv6. Now I'm telling you all this, but I will delete all this and we will do this from scratch. Okay, so don't worry. I'm just explaining. Now you see here that you see IPv6 EIGRP 100. And that's the new thing, which is I explained in the book as well. Now with the routing protocols for IP version 6, you're enabling them. You still go to global and you say, hey, IPv6 router EIGRP 1. Okay? That creates a protocol instance, or really it's a process, I'm sorry. It's a process, okay? And you hit enter. Then you give it a router ID. That's kind of weird. We only did that in OSPF. But now that router ID, that becomes a protocol instance. And what I do is, I normally use like if it was a virtual IP address, 1.1.1.1.1, I will do something like that. That would be the router instance. And then you have to actually turn on the protocol. But still, that's only one part of it, all right? Which is what's cool about now when we configure these routing protocols is the fact that we have to do it on a per interfaces. And all we do, there's no network entries. There is no network entries anymore. You don't have to worry about, oh man, did I advertise this network? No. Now what you need to worry about is the interface that you want to participate with this routing protocol is where you go ahead and enable it. So you go inside that particular interface, like you see here, the sub interface, because we're router on a stick, right? And then I go ahead and I enable IPv6 EIGRP. And what's important here in EIGRP? The 100, the autonomous system. That's what's important. So we'll go to every interface, and I will do the same thing. IPv6 EIGRP 100. And then I have my serial IPv6 EIGRP 100, where the IPv4 routing protocol, router rip, you have to do all that. I didn't do no auto summary with the EIGRP before you had to. Or else it will not communicate, because remember, RIP and EIGRP are still considered distance vector routing protocols. But because we're now going into the actual interface, now there's no need. We're not advertising networks. We're actually advertising the interface that it's in. And really, when we advertise networks, that's what we're doing. Hey, this network is attached to this interface, therefore advertise by putting the auto summary with send the mask out on the updates. There is no mask anymore in IPv6. No need for that, because that prefix length that we use in IPv6 is only for routing purposes. Okay, only for routing purposes. All right, so you can see there both EIGRP and RIP are configured on there. Okay, and you can see how I configured IPv6 router EIGRP 100. Okay, the router ID, which is the protocol instance, and then the no shutdown. All right, and then I didn't do all the other stuff like the line con, aux, all that stuff. That's just very basic stuff. Okay, and again, and you repeat the process in the second one. So what we're going to do is, now, one thing I'm not going to do is get rid of this. I'm sure all of you know how to put in the IP address. Okay, you have the networks, okay, which they're right there. You have the 10.0, 20.0, 30.0, 40.0, and then you have the 10.114 in between these two. Okay, and then you have the 2000, the 2400, the 2800, the 2C, I believe over here, the 2C, and then the last one, which is 3000 in between the routers. So you create the lab, you label it, you make sure where everything's at, you put it in the IP addresses. What I'm going to show you is how to create the VLANs, how to name the VLANs, how to assign the VLANs to the ports, trunk the ports, okay? And then more importantly, we're going to go ahead and go into the routers and start configuring first IPv4, get our connectivity going across, just so we can make sure, rule out any problems, and then we'll go ahead and put in our IPv6 configuration. So what we need to do is delete the VLAN .dat file in our switches, and we need to erase the startup configuration, and we need to erase the startup configuration in our routers, and obviously we need to reload all this for things to take effect. So let's go ahead and do that now. Let me go ahead and go into this switch right here. Let me put this mouse down, and let me try to use this as best as I can, so it doesn't take me 2 years to do this. Okay. All right, so I'm being told that I'm in the way. Okay, so I hope you can see it there. Okay, I can't stretch out my hand too much. Okay, so all that we're going to do is delete VLAN.dat, D-A-T, delete VLAN.dat. That's the first command, not the first command, but that's one of the commands you want to do. You want to delete the VLAN database. It is case sensitive, so if you're working in uppercase, make sure that the file name VLAN.dat is in lowercase. You hit enter. It's going to ask you to confirm. You're going to hit enter again. All right, and then you're going to erase the start. Enter, enter. And then you're going to reload. Reload. Okay. I'm going to minimize, not close, minimize. I'm going to do the same thing to the router on the right. I mean, not the router, I'm sorry, the switch on the right for VLAN 20. I'm going to enable, delete, and if I'm in the way, let me know. I have an administrator that's sitting right there in front of me, and they'll just slap me and tell me to get out of the way. So if I'm in the way, let me just move this to one side so you can see it. But just let the administrator know they're watching, so to make sure that I get this done right. All right, deleting the VLAN.dat. All right, you can see that. All right, delete VLAN.dat, and then it'll tell you that's the name, and then to confirm, and all you have to do is erase the startup configuration, which I'm sure a lot of you already know this. Probably this is just a refresher for you. Okay. Hey, look, I did it by itself. It's pretty cool. This laptop has a mind of its own. I love it. Go to the core switch. Again, let's open this up just a tad bit. And let's move this over here so you guys can see it. Right there. All right. Enable, delete, VLAN.dat, not date. Confirm, erase the start, and then reload. Okay? Very simple. All we're doing is just getting rid of everything that's there. So we can do it from scratch, you know, practice it. And then again, I will minimize it. If it wants to minimize, I don't know. Sometimes it says I don't want to. All right, let me go ahead. Use my left hand. My right hand's getting kind of tired. I'm going to go in the router. Router 0, or the router on the left. All right, router 1, router 0. That confuses some people. Because for me, that's router 1, not router 0. So whichever you want to call it, router 0, router 1, the router on the left. And then I'm going to go ahead and do an erase. Start, enter, enter, and then reload. And then let's go ahead and do the same thing for the router on the right. As you can see, all these things are saying down, 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 because we're getting rid of the configurations. Let me move it further down this way. Come on now. It's my left hand, but you know what? It's still... Oh, it likes the middle finger better. Okay. What? All right, so enable, erase start, reload. All right. Now let's go to the core switch. And we're working our way around the world. All right, let's move it over here. CLI. Tap in there. Enter. Delete. VLAN.dat. If I'm making funny faces, it's because I'm moving my right hand. Okay. Erase. Start. Reload. Okay. And let's go down to the 2 other switches. Again, there's more this way so you guys can see what I'm doing. CLI. Tap in there, make sure it's in there. Enable. Delete. VLAN.dat. Oh, look at that. Delete VLAN.dat. Erase. Start. And reload. Okay. And now we go to the... We did that. We did the course. Whoa. I know we did the core switch already. And now we're going to go ahead and do this switch. Wow. Okay. I'm in there. Enable. Delete. VLAN.dat. And erase. Start. Reload. Alright, so we erased all our configurations on our inter-networking devices, which is our switches and our routers. There should be nothing there. We'll verify before we begin to actually configure to make sure. The only thing that we didn't take out was the IP addresses on each particular switch, on each particular PC. okay? Because I'm sure you guys know how to put in IP addresses on the PCs, okay? So we're not going to go ahead and worry about that. But now, let's move this down here a little bit because we're going to be working with the switches right now, okay? So that way we can see which VLANs we're going to do first. Now, first of all, we're going to be working with VLAN 10. So on this switch, we're going to go ahead and give it a name. We're going to go ahead and give it a host name. We're going to go ahead and create the VLAN, and we're going to go ahead and assign the VLAN, and then we're going to trunk the port. All right, and then we'll go to the next switch and do the same thing. Very simple, no biggie. We're not worried, again, we're not worried about a spanning tree protocol. We're not worried about turning off spanning tree or anything like that. We could if we wanted to, just to tweak the network, doing the spanning tree BPDU guard. I'm sorry, spanning tree port switch port or spanning tree port fast. I'm sorry, spanning tree port fast on whatever range of ports to turn off spanning tree. That way, it automatically puts the port in forwarding. All right, and then we can guard against it by doing the spanning tree BPDU guard enable. All right, that's what it does. It watches to see that, hey, be careful, don't plug in a switch there. You're going to go ahead and create a loop, so it shuts down the port. But again, the lab was not for that. All right, it was a VLAN lab with IPv6. But again, if you got questions on this or you want to see something like this, you let me know. All right, so let's go ahead and create the VLAN. All right, and where will be the best place to put this, I guess, so you guys can see it? I wonder if you can see if I put it right here so I can be in front of it, and you guys will be able to see that. Miss Administrator, can they see it if I put it right there? I want to make sure that they can see it. Okay, perfect. So it gets behind me, and they can see what I'm doing. Okay, perfect. All right, so this is the first switch, so we'll keep the name simple. Config T, host name, SW1. So we want to keep it, let's not go crazy with the names, underscore this, and all this craziness. All right, switch 1. So now let's create the VLAN, VLAN 10. Now, once you do that, you've created the VLAN. The naming of it is completely up to you. All right, now you would want to name it, or else it's going to give it a number, 0010. All right, so give it a name. Let's call it name, like I think I had before. I put faculty. Let's call it faculty. Just to keep it along with the lab. Okay. Now we went ahead and actually created the VLAN, and we named the VLAN. Now we want to assign the VLAN. I'm not going to assign it on a port by port basis. I'm going to go ahead and assign it based on a range of ports. So what do? Int range F0, not F0, yes, F0 /1-10 like we did before. Okay, so now you're in the if range. Now whatever you do there, okay, it's going to affect all those ports. That's where you do your switch port security, your spanning tree port fast, your BPDU guard enable, you assign your VLANs. So everything that you do there, but all the ports on switches are normally set to dynamic auto. And in order to assign a VLAN or to turn on switch port security, these ports must be placed in access mode. So the first thing you need to do is put the ports in access mode. No big deal. So switch TCH. I have to say that, else I'll misspell it every time. And now I can't type. TCH, switch port mode, access. So that's the first thing you do. All right, you need to turn those ports into access ports. Now, switch port, what type of access? Access, well, VLAN 10. You see what I tell you? Each and every time, no matter what, I always misspell it. That is just something with me. I don't know what I do that. I'm going to do an up arrow to bring that command back. I'm just going to do an arrow to the left. And why is that happening? Arrow to the, okay. Oh, okay, because I'm near the board. That's why that's happening. Okay. So I'm going to go an arrow to the left to get rid of and do CH. Switch port access VLAN 10. Now, that's the correct command. So let's go ahead and verify. Now, in your certification, and I've said this in many videos before, no, you have to go back to privilege mode in order to do a copy run start. You have to. There's no other choice. You may have to type copy running -config startup -config. I doubt it. You probably just have to do a copy run start, but you have to go back to privilege mode. Here in the lab, we don't have to do that. That's why from 12.3 or 12.4, they came out with the do command. From right here, I can do a do copy run start. That's a wrap. But start from wherever I'm at. So I just hit enter. And it's going to ask me, hey, is that the file name you want? Sure do. All right. And from right there, I'm going to verify to see if actually this took effect, what I just typed. So I'm going to do a do show VLAN. If not, if I were to type, if I would not, okay, can't talk now. If I didn't type the do, I could not just do show VLAN. All right, because I had to go back to privilege mode. So I'm doing do show VLAN, so I have to go back to privilege mode. I'm going to hit enter. Let me separate from the board because it's kind of sensitive there. There's our VLAN. And there are the ports that we assigned it to. So we created our VLANs, we named our VLAN, and then we assigned it to the ranges that we wanted to. Now, we have to go ahead and I'm going to do a Control-C and trunk the port that's going up to the other switch. So what port is that? That is port 22. So I'm going to go from right here, int F0/22, enter, switch TCH, port mode, instead of access, trunk. Now that trunks the port. Okay? So the VLAN will be allowed to go through that port. Okay? And how do we look at that? Well, do show int trunk. And you can see that on port F022, you can see it right here, F022, the 8021Q encapsulation was turned on, and the status of the port is trunking, and then native VLAN is on. Okay, so you can see that your trunking is on. And that's one of the things that you want to take a look at, especially in the certification, not so much as far as the simulations, but on the print screens. When they give you, a lot of the problems is that one VLAN is not talking to the other VLAN because they forgot to trunk the ports. The ports are still in access mode. And if you're not the native VLAN, you're not going to be able to go across the actual wire, right? The actual port that's connected to the other switch. The way they trick you in one question in the certification is that they're calling one VLAN the admin VLAN because they created a VLAN called admin. They put all the VLAN, they made it the native VLAN, all right? They put all the ports on that VLAN because you're going to see that VLAN 1 is empty. So that is your native VLAN. That's why that admin VLAN can talk across, but the others can't, okay? Just take a look and see which is in access and which is in if it's access mode or trunk mode. That's the things you need to look at. All right, so we've done with this switch. We created it, we did everything, so we're done. Let's go ahead and close out that switch. Let's go to the other one, which is going to be VLAN 20, and I'm going to put it behind me, right over here, so you guys can see that. I'm going to open it up a little bit here. So I'm going to enable config T, host name, that's W2, all right, VLAN 20, name students, okay, Now we need to, in order to assign it, we need to change the ports to access ports. So we need to go into the range of ports that we want. Int range, don't forget the range command, int range f0/1, and again we'll do -10 just to stay consistent throughout the lab. Switch tch port mode access, and then switch port access VLAN 20. So again, created it, named it, turned the went inside the ports we wanted to assign the VLAN to, turned them into access ports, and then actually assigned it using the switch port command. And yes, I did forget a T, but remember, if you type enough of the command, the iOS is going to know what is it that you want. If not, it'll give you that carrot symbol, say, hey, this is an error. All right, now we need to trunk that port. And I believe we're using port 22 again here, because I like to try to be consistent. Oh no, there's port 23. Okay, never mind. So this is port 23. So int f0/23 switch tch port mode trunk. That turns it on. You know, I never did. I said do copy, run start. And again, I can't emphasize it enough. In your certification, you need to go back to privilege mode. So we're done with that switch. So now we're going to go ahead, and you can see how the lights turn amber because you're changing the modes of the port. All right, now we're going to go ahead and go into the core switch. Now really, in the core switch, since we're not doing STP, we're not worried about anything like that, all we need to do is give it a name and trunk the appropriate ports. That's it. That's all you got to do. Okay? All right, so we're going to go enable, config T, and then we're going to go and 22, 23, 24. So we're going to go int range. Well, let's give it a name first. Host name. Ooh. Host name core 1. And then we're going to give assign or create trunk the ports. They need to be trunked. Int range f0/22-23. There's a method to the madness why I do things a certain way. See how easy that was? If it would have been separate, then it would be a little bit of a different story. And then switch tch port mode trunk. And again, I don't think you're seeing this because I never moved this way. Okay. All right. You can do a do copy run start, and then do show int trunk, because really that's all we need to verify that we did here. But what you can see here, which is interesting, I'm sure you know why, right? Just in case for those of you that don't. All right, you can see that ports F022 and F023, they both have the trunking on, but F024 is not. And the reason for that is because the router, right? That router's interface, come on now. That router's interface right now is off. That's why you don't see it. That's why you don't see that port is trunked. Once we go in there and we configure it, then you'll see the trunk port. Remember, right now we're configuring everything for IPv4. Once we go around and we get connectivity, then we'll go ahead and put in IPv6. All right? So let's go ahead and open up that router because I want to. Okay, thank you very much there, Mr. Router. Let's put this over here. Okay. Now we're all very familiar with this screen. And as I've told you in the past, I do not use setup mode. Everything is done from scratch. Okay. We're going to say no. Enter. Enable. Config T. Host name. And we'll, very simple. R1. Even though the label says R0, don't let that confuse you. This is the first router. So R1. Okay. We're going to the fast Ethernet 00. But remember, this is a router on a stick. So we don't put an IP address on the physical interface. All we need to do is just turn it on. Okay. So int f0/0, enter, and then no shut. So that turns on the interface. Now we start creating the sub-interface. We need to create a sub-interface for VLAN 10. And we need to create an interface, a sub-interface for VLAN 20. Okay? So I'm just going to use an up arrow so I don't have to type a lot. So we got int f00.10. That's how you create a sub-interface. The next thing that you must do is the encapsulation. If you don't do the encapsulation, it will not allow you to put an IP address. So we're going to do encap, short for encapsulation, dot 1Q, which is the 802.1Q, and then a number. And this number is a VLAN ID number. This is the VLAN that you created. And since this is for 10, you must type in 10. Okay? You type any other number, it's not going to work. Your sub-interface number can be whatever you want it to be, but if it's cool, if everything matches up together, so it causes less confusion. All right. Now the IP address 192.168.10.254. That's the gateway, right? 254 with the mask of 255.255.255.0. Again, I got close to the board. That's why that happened. Again, this is the IPv4 version of it. Let's go ahead and do the next sub-interface. I'm just going to up arrow, make life easy. Sub-interface 20, right, for VLAN 20. Then up arrow again for the encapsulation. We need to change it from 10 to 20. And then the IP address. I was going to arrow to the left. And let me move this way. You guys can see that, right? Arrow to the left. And then just put 20 in there. Okay? And then I'm going to do a do copy run start. Enter. Enter. I'm going to do a do show IP int brief. Alright, as you can see, that everything is up, or it should be up. Alright, shows up. Everything should be okay. Alright, let's go back to that core switch. Let's see if we see that port that's trunked now. Do show in trunk, and that's interesting. All right, let's do this then. Int f0/24 switch port mode trunk. All right, now it shows up. Don't know, I didn't show before, or maybe I didn't see it. My eyes were playing tricks, but now it's there. Okay, now it's there. All right, so let's see. Let's first check before we start doing anything else, configuring anything else. Let's verify. See if we can ping from VLAN to VLAN. As you can see, that this is still amber, and I just deleted the cable. Can't do Control-Z, huh? Oh, I just got rid of the cable. Let's put it back in port 24. All right, so let's wait for that to turn green. And there's one of the reasons that you may want to, in some switches, turn off spanning tree because of this waiting period. Saying, hey, who are you, right? Should I, block you, put you in forwarding state, disable you? What is it I should do? So that's what spanning tree does anyway, because it's on every port. So now we just wait. It turned green. Lovely. All right, so we're on a PC. Which PC are we on? Let's go ahead. Let me close this. Let's bring it down. Since we configured already the VLANs, I should be able to ping from VLAN to VLAN. No need for a routing protocol. These are directly connected routes. Okay. So we're going to go ahead and go to command prompt. First, let's ping our gateway, 192.168.10.254, and we get a reply. So we know we can reach our gateway. Perfect. Let's see if we can reach the other gateway, 20.254. And again, this is just a step-by-step process, troubleshooting, see where we can go, what have you. You can just simply try to ping the other way, and then you can do a tracer, things like that. But I like to go check as I go. And then the other one's 20.1. And remember now, maybe it's getting through the ARP. That's why it usually takes one timeout before it gets to the other side. And now there you go. So we do have connectivity. We do have connectivity. And my shirt just loves this board. Okay. We do have connectivity here in this particular LAN. We're good to go. Now we're going to do the same thing over here. The exact same thing that we did. Okay, we're going to do it right here. This is VLAN 30 and the other one is VLAN 40. So let's move this all the way over here. Okay, so now we're going to do VLAN 30 and VLAN 40. So let's go ahead. Where's my mouse? There's my mouse. And we'll go to that switch. Okay, that's for right there. I'm going to hit enter. Going to enable. Config T. All right, this is going to be switch 3. Okay. Host name SW3. Enter. VLAN. VLAN 30. Name. Let's call this faculty 2. Assign them. Int range F0/1-10. Change it to access mode. Switch TCH port mode access. Assign the VLAN. Switch port access. Oops. VLAN. Not easy. 30. All right, so we're good there. And then we need to trunk the ports. So again, here we got 22 and 23 again. So we're using the same ports that in the previous one. So in this case, int F0/22. Enter. Switch port mode trunk. Enter. Do WR. I'm going to do a Control Z. As long as I don't touch the board, right? Control Z. Show VLAN. All right. Let's bring it up here to verify that indeed that got created. And it's got assigned to the ports. You can see a little bit over there. Let me open it up a little bit more. You can see that it got assigned. All right, and then let's do Control C, and let's do a show int trunk to make sure that we did trunk that port, and you can see it there. Okay, repetition breeds retention. This is one thing that I learned over the years in teaching, but also in the military. One of the things that you do every day is drill, 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 drill. If you do this every single day, every single hour of the day, it's going to become second nature to you. Okay. For some of you, it may be a little bit like, okay, I've done this before. It looks like, but the more you practice this lab, the more you see this recording after you've logged out of the live session, and you look at the recording again, and you look at it again, and you practice it, and you do it, and you do it. You're gonna get. It's gonna become like, oh, okay, I get it now. It's second nature, just like anything else. Okay. All right, so we're done with that particular switch. I'm just gonna close it. All right. Now we're going to go to this switch right here, which is VLAN 40. Let me move it over here. Okay. And let me open it up a little bit. This is going to be switch 4. Conf T. If you write enough, the router's going to know what you want to type in your certification. Please type the whole command. All right. Give it a host name, switch 4, host name, SW4, and then create the VLAN. VLAN 40, name student 2. Again, I'm not very creative with the names, but again, so that you can understand how the command is. And then the range, int range of the ports you're going to assign them to, F0/1-10. All right, and then you got to change it to access mode. Switch TCH port mode access, and then actually assign it. Switch TCH port mode, access VLAN 40. Enter. And then we go into port 23, which we already found out that that's the port facing the switch on top, and trunk it. Switch, let me get away from the board. Switch port mode trunk. And I didn't say I didn't say my little ditty there, so I misspelled switch port. CH, okay, and trunk support. Control Z, WR. Somebody, one of my students wrote to me, hey Laz, what does WR mean? WR is a shortcut for copy run start. Are you going to do it in the certification? Nope, you better not to. You're not going to be allowed to do it. Okay? In the real world, can you do it? Of course, depending on the iOS. All right, depending on the iOS. But if it's an iOS 12.4 or what have you, other than the XR, you can do WR every day of the week. It's just going to do the same thing as copy run start. Okay? A shortcut. Show int trunk. Let's take a look at that. There's your port 23 with the trunking protocol. Let's look at the VLAN. And then let's scroll up a little bit here. And you can see that that VLAN is created. So we're done. What we need to do though, we need to go now to the core switch, okay, and we need to trunk name it and then trunk the appropriate ports like we did to the other one. Okay. Wow, this is way over here. Okay, let's put it over here. All right, let's go. Enable config T, host name, core 2. Let me open it up a little bit. And interface range F0/22-24. Switch TCH port mode trunk. Okay. Oof. I didn't like the fact that that didn't go up. Okay, let me check the switch real quick. Trunking is on there. Okay. And we did check this one, right? Trunking is on there. Okay. And switch port 22, 23, and 24. That should be correct. Yes, it is. Okay. Do WR for a shortcut. Do show int trunk. And scroll up. 22 and 23. Okay. So now let's go to the router. All right. On the router. Remember, router on a stick. Router on a stick. Okay. Now here, the 1020, this is 30 and 40 for your IP addresses. Okay. So we're going to say no. Enable. Config T, configure terminal. Host name R2. Interface F0/0. All we got to do there is just do a no shut. Just turn it on. No shut. Okay. Now, let's up arrow, make life easy. We're going to do the first one for 30. Sub interface. we got to do the incap dot 1Q, right? 30. It's got to match the VLAN. And then the IP address. IP address 192.168.30.254. 255.255.255.0. Enter. Let me open it up a little bit further so you can see the subnet mask correctly. And let me move it more this way. Okay. All right. So again, we're going to up arrow this time, so we have to type less. Okay. So we need to create a new subinterface for 40. We need the incap for 40. And we need the IP address for 40. And again, we're going to go arrow to the left. Make that a 40. Okay. Control Z, WR. Just doing a bunch of shortcuts. Just making it same thing as going exit, exit, copy, run, start. Just doing it quicker. So we should now have connectivity between these two PCs right here. So we should be able to go back and forth. Remember, information is going to go up to the router. The router is going to look at its routing table, right? Let's take a look at the routing table. Show IP route. It's going to see two connected routes. So you should be able to ping from one PC to the next. So let's make sure, we want to verify that that indeed is happening. Go to the, oh, so Jesus. Well, it's maximized, that's fine. Go to that desktop. Well, it's too big, I don't want that. So over here. Go to the run and type ping 192.168. Let's go all the way. Let's go for it. 40.1. Let's see if we can make it to 40.1. We know that we're okay. And we did. So we have connectivity there, our configurations for our VLANs, our trunking, our router and stick configurations, all that's good to go. Perfect. Perfect. Now what we have left to do, we have to configure. How did I lose my cable there? Okay. Let me get a cable. I'm sorry. Somebody keeps stealing my cable. I think I don't have the door locked in the office and they keep coming in. So let's plug back in there. Fast Ethernet 00 224. That's a 16. Touchy, touchy. All right. Let's do it this way then. Straight through cable. 24 to 0. All right. Now what we need to configure is the serial interfaces on the two routers. Okay, the serial interfaces on both routers. Let me see if we can see this a little bit better. Let me move it, or you can actually, if I can find my mouse on the board. These glasses ain't helping much. Okay, so we're gonna put the address here as 5 and the address here as 6. Okay, well, what's important about this one is we need to give it a clock rate. All right, it's a serial interface, not a fast Ethernet interface. So we need to make sure that the clocking is set. Okay, so this is the interface where we're going to put the clocking on. So let's go ahead inside there. All right, that's S010. S010. Okay. Router 0. Let's put the line. Let's put that over here. Okay. So we're going to go enable, config T, interface S0/1/0, IP address, and it's 10.1.1.5. We have a CIDR 30. That's a 252 subnet mask. All right, so we're going to go 255.255.255. Oops. 255.252. Enter. Clock rate. The faster the clock rate, depending on cables you have, of course, the better. Okay, and then we turn on the interface. No shut. All right, and I'm just going to do a WR. And then on the other router, on this router right here, it'll be the same thing, but we don't need a clock rate. This is the S011. So all we're going to do on that router is actually just put the IP address and turn it on. So we're already here. Config T, interface S0/1/1, IP address 10.1.1.6, 255.255.255.252, enter, and then no shut. Do WR. So we now have everything. It's all configured. Okay. We should be able to ping from router to router. Now I'll check it there in a second. Okay, that we can ping from router to router. All right. But then of course we're going to need a routing protocol, right, to get from point A to point B and vice versa. So let's make sure that we can ping from, let's say, this router or from this interface, because we know we can get to our gateways. Let's say we can ping from this interface to the other interface on the other router. So let's go ahead and go inside that router. And I'll do a Control Z just to get into privilege mode, just to be there. So I'm going to type do ping 10.1.1.5. And we can. So it's great. So what we're going to do is we're going to configure RIP version 2. Now remember, with routing protocols, at least for IP version 4, we have to advertise the networks that we're connected to. So with router 2 over here, we're connected to 3 networks. We're connected to the 192.168.30.0, 192.168.40.0, and the 10.0.0.0. Why do I say that when it's really 10.1.1.4? Because it's a distance vector routing protocol. It will summarize it. If you put 10.1.1.4 and you do a show start, you're going to see that's going to show 10.0.0.0. Okay? So that's why we have to do the no auto summary, no auto hyphen summary command to be exact. So when it sends out its updates, it's going to know, hey, I need to send the actual subnet mask out. If it doesn't, it's going to think that's in the 10.0.0.0. So we don't want it to summarize on the updates. So that's why we do the no auto summary command when we do distance vector routing protocols like RIP and EIGRP. Okay, so let's go ahead and do RIP config T. Oops. If you fall into this problem, it's a keyboard combination, Control-Shift-6, takes you out of anything, breaks out of anything. Config T, router, RIP, version, very important, 2, network, 192.168.30.0. I'm going to up arrow, put 40.0, and then network 10.0.0.0, no auto summary, hyphen summary, sorry. Do WR or copy and start, what have you. So we got RIP configured. Now we got to go to the other router, and we need to tell that router, hey, these are the networks you're connected to. We need to tell the routing protocol, hey, these are the networks you're connected to. Go ahead and snitch yourself out to the other router so you can converge, and everybody will know about each other's networks. Okay, so let's go ahead and minimize that. Let's open that router up. Wow. Okay, I think we can, right there. Okay, that's exit 1. That's being global. Router RIP version 2. network. Now this is the 10 and 20 network. 192.168.10.0 up arrow 20.0, and then we're still attached to the 10.000. Yes, you got to put it. And then no auto hyphen summary. Hit tab to finish the command. And then do WR. So if all is working as it should, I should be able to do show IP route and see a couple of R's from the 30 and the 40 network. So I'll go to privilege mode by doing a Control Z. I'll do a show IP route. And there we see, like I said, a couple of R's, right? With, hey, they're one hop away. We're using the RIP. You got the R right there and the administrative distance, right? Which is 120. All right. And now we should be able to ping from PC, the very first PC, to any other PC. So let's go ahead and try to do that. Let me just close that right there. Let me open up that PC, move it over here. So let's up arrow. So we knew we can put the 20.1. Let's do 30.1. And remember, it's going to take a little bit. It's got to go across. All right. And we do have that ARP request. So there's your reply from 30. And then we do 40. Okay. And there we have 40. So now with IP version 4, and I'm sure you guys are like, okay, we know how to do this, Laz. No big deal. Okay. We have IP version 4 running on this network. But now we want to move forward in technology, right? We want to be like the rest of, the world that's changing over to IPv6. Well, we already got our IPv6 addresses, right? So now it comes time to go ahead and put it on your routers, okay? Now, our PCs already, let me close the command prompt here, already have the IPv6 address, right? And for the gateway and everything. So all we need to do is go in the interface, that same sub interface, and put that IP address you see right there, because that address is going to be our gateway address. Okay? So let's go ahead and start doing that. All right, so a lot of copy and pasting now. That's the only thing with IPv6 is the fact that these addresses are so huge. Even though they have the short expressions, they can take out the leading zeros and all that. It's still a big address. So definitely, Excel, Notepad, all these things are going to be your friend when it comes to doing IPv6. All right, let's go into the router. Let's put it over here. Oops. All right, put the mouse down. Click in there. Conf T. Interface F0/0.10. Enter. Now, how do you put an IPv6 address on an interface? Well, IPv6 instead of IP. Address. And now I'm really going to have to open this up because it is a big address. You need to be able to see it. Okay. And you know what? Let me turn this back on. Do a paste. All right. And this is going to be a /54. Enter. There, do enter. One too many S's. I apologize. I got happy with the S. All right. So you can see that it took it. It didn't give me an error. I didn't do IPE. V6 unicast routing, so it allowed me to put an IPv6 address. That's not what it's for. I didn't have to do IPv6 enable because IPv6 enable is for you to use link local addresses in order to go ahead and do your networking. Here we're actually putting in a static IPv6 address. That's it. All right, that's all there's to that. Okay, so let's check from the PC, and I don't know if you can see that. I'm going to get out the way. Maybe I'll come off camera, but I want you to see the full command. All right, IPv6 address, the actual network prefix, ;, and F with the prefix length. All right, /54, which is great because remember there is no subnet mask. So let's go ahead and see if we can ping that because we do have that in our PC. Come on. Okay, so let's ping, and again, right-click paste because typing all those is going to be a lot. You hit enter, and you see you have a reply from your own gateway. All right, so let's do the same thing for VLAN 20. And VLAN 20, okay, VLAN 20. The address is going to be this one. So let's copy that. Okay. Let's go to the router. And then, of course, that's going to be under subinterface 20. So I'm going to go ahead and up arrow. Okay, up arrow 20. We're going to hit enter. Now we're in that subinterface. We're going to put IPv6 address with 2 S's. Right click paste. You can see that's the next network, right? 2400F. We put in the CIDR 54. That's what we figured out at the beginning. And then let's copy this. Do WR, and let's make sure we can ping it. So ping, okay, right click paste, and hit enter, and we get a reply. Awesome. Okay, so we're doing good. We're getting replies back and forth, but let's see if I'm sure we can ping the other PC. We'll check that when we do the full routing. Okay, let's go ahead and go back to the router, and we're going to do the serial. Now in the serial, so you have the 3000 address. Okay. Okay, let's put this right here. Let's see where you can see that right there. We're doing S010. S010. Okay. Int S0/1/0. Enter. And there's where your notepad comes in handy. I know we're doing the 3000 address. So what I'm going to do is I'm just going to copy this whole thing, Shift Home, Control C. And I hope I copied it. And then I'm going to do IP. Oh no. Yes, IPv6 address. Right click paste. But that's the network, right? 1. That's the first address on that router right there. Right? I'll put it right here. You're in the interface. Okay, we'll put it here. And then that way I'll just move out of the way. Okay? You went inside the interface. You want to sensitive board today. IPv6 address, the IPv6 address, :1, first available address, with the prefix length. Okay? We're going to hit enter. All right, and that's what we really need to do. Do WR. But what I am going to do is I'm going to copy this command right here. Okay. Then I'm going to go to the other router under that interface, S011. All right, interface S0/1/1, enter. Right click, paste, and just change that 1 to a 2. Enter. DWR. Again, now no big deal. No big deal. There it is. IPv6 address, and then the actual network prefix, : all zeros, but we're going to take out the leading zeros, and then the 2 with the same prefix length. So I should be able to ping, and now I'm going to do a paste again. But of course, boy, I'm going to ping 1, and I should be able to ping. Oh, silly me. Just ping, right? All right, and we got four bangs, so we have connectivity IPv6, all right, across that way. Now what we need to do is put the gateways, all right? So we need to put the gateways on these sub-interfaces for these two PCs right here. So that one's going to be, you can see it right down there. IPv6 is not as hard as it looks. It's just that we're not used to working with it. We're not used to working with it. That's all it is. All right, let's go to the router. That is sub-interface 30, right, for VLAN 30. Conft interface F0/.30. Sorry, 0.30. Excuse me. All right, IPv6 address. Right click, paste. And then, of course, the prefix length of 54. I think my shirt touched the thing again. /54. Enter. Okay. So we got the address in that one. Now I got to do one for 40. So for 40, we got to go to the PC. All right. On the PC. And then that's the gateway address right there. So we're going to go ahead and copy that. Control C. Go into our router since we're already there. And we're going to go IPv6 address. Oh, I got one too many D's this time. Got a trigger finger. Control E takes me to the end. Right click, paste, or just click on paste, and then /54. Control Z, WR. Now let's see if we can ping all right, let's do this. Let's recopy. Control C. There's a gateway, okay? And I'm sure we'll be able to ping the other one as well. But now, we need to get across. And we're going to use EIGRP for the configuration. We're going to use EIGRP for the configuration, okay? So let's go to the first router. We're going to go to global. We're going to exit. We're going to go IPv6. I think I have to start with IPv6. Router EIGRP, and just to say true lab 100. Look, it told me, it gave me an error. Why is that? Because now we're routing. Now we want to forward IPv6 information. So what we're going to do is we're going to go ahead and go IPv6 unicast routing. Now we turn that on. And now we can do that. Okay? All right. So we did the first portion. Now we got to give it the router ID, which is it's considered a protocol instance. Router ID, tabbed it, 1.1.1.1, enter, and you must turn on the routing protocol. No shot. If you do not do that, it will not work. Okay? You must give it the router ID. You must turn on, most importantly, the autonomous system, which is 100. Okay? That has to match. That hasn't changed. Using EIGRP, the autonomous system must match across all the routers. All right? But again, look, I didn't advertise any networks. So how does it deal with what networks are advertised? Because we got to go on an interface by interface basis. So which router are we in? This is router 1. It's the router over here. Come on, mouse. Where are you? All right, so there are the interfaces right there that we need to deal with. F010, and then the F00.10 and F00.20. So let's do that first. F00.10, IPv6, and just so you can see, EIGRP 100. Easy as that. There I put 0, there I put 10. I put 0 there now. Okay, no worries. IPv6 EIGRP 100, and then the 20. All right, let's do a Control Z, WR. Let's do a show start. And let's take a look at what we've done. I put IPv6 EIGRP 100 in there by mistake. Okay, that's what happens when you fat finger the keyboard. All right, but I have it where it counts. F0.10, 100. There it is. F0.20, 100, and you can see both IPv6 addresses are already on there. Okay. So now let's, I'm going to have the serial. Forgot about the serial. And in the serial, look, we have to enable it in the serial. So Control C. Wow. COMT interface S0/1/0. All right, and we want to go ahead and do IPv6 EIGRP 100 to WR. All right, so we're done. We now told the routing protocol that we want these 3 different interfaces to participate in the autonomous system EIGRP, right? In the EIGRP process. All right. So let's go to the other router and do the exact same thing. Nothing really, I mean, except for the networks, it's the same command, And the cool thing is we don't have to worry about, oh, you got to type in the networks. No, just go to the interface that enable the routing protocol. It's much easier. So config T, IPv6, EIGRP, or router EIGRP, I'm sorry. Router EIGRP 100. Again, I forgot to turn on IPv6 unicast routing. Okay, there you go. Turn on unicast routing. Now we can do the 100. Router ID, let's tab it. Let's do 2.2.2.2. This is, again, a protocol instance. They don't have to be the same across the routers. And then do a no shot. Now we go to the interfaces. This is 30 and 40, and then whatever the serial is, which is 1, 1. So interface F0/0 dot 30 IPv6 EIGRP 100 40 100, and then S011 S0/1/1 100, and you can see that now an adjacency has happened, okay, which is a good thing. But now let's see if this is really working. We know it's working with IPv4, okay, because we saw the R's, but show IP route. Let's see. Well, I still see R's. What's up with that? That's right, because now we do show IPv6 route to look at that routing table. Show IPv6 route. And now, well, I guess I typed it on the other router. I'll type it in this one. Control Z. Show IPv6 route. Step away from the board. Okay. And now you can see that we have D's, which means dual. I think it's dual. That's what I call it, because that is EIGRP. So we're actually routing across using the EIGRP protocol. But you can see they can have two separate sets of IPs, IPv4, IPv6. Okay, you have two routing protocols, one for version 4 and one for version 6, with two sets of routing tables, which is great, because if you are an enterprise, it's all IPv4. What are you going to do? You're just going to say, hey, everybody, turn down your IPv4 protocol, and we're just going to implement IPv6. No, that's why we have the dual stacking. That's why we can use both. And then once we have full connectivity through IPv6, we can slowly start getting rid of the IPv4. All right, but let's ping just to verify. Control C. Let's go ahead and let's open up this PC right here. We'll use this PC as an example. All right, open up my notepad, and this is the network on the other side. So let's grab that number right there. That's why I copy paste. Copy paste. Documentation is going to help you very much. Ping, right click, paste. Okay, and then 1. And you get a reply with the IPv6 because you're using the routing protocol for IPv6. Okay, it's getting old. Okay, and then let's pick the other one, which is, oops. Whoa, Control Z. Okay, which is 2C. All right. Let's back this up. Really, all I got to do is just do 2C. 2C, 00, : 1, and you get a ping from that. That's it. It's as simple as that. It's not a big deal. You got to get organized. You got to get organized. You got to set your IP scheme before you even go ahead and start. Create those VLANs. Assign those VLANs to whoever you're going to do it to. If it's a router on a stick situation, make sure that you have the right type of encapsulation. There are other routers that support ISL if you're still using ISL, which doubtful. All right, everything's pretty much 802.1q. But make sure that the trunking of those ports are on and that you're using the right VLAN ID for the VLANs you want. And if you're going to use an IPv6 routing protocol, don't forget, like I did, you have to turn on IPv6 unicast routing. That is its purpose, for you to be able to route IPv6 packets. All right. You put your IPv6 addresses, where, statically, or if you want to use the EUI64, it's completely up to you for the auto configuration. Statically, it's not a big deal. You can see it's just the last interface portion is all zeros, ones, or whatever you want to use. And then you go and do your routing protocol. You go in global. There's different ways that you do each one. They're very similar to each other, but then you advertise it on the interfaces that you want that routing protocol to do. We've come to the end of the lab. This is it. That's all there's to it. It really is just getting organized and being familiarized with IPv6. Let's say don't save because I didn't do anything to change it, but it really wasn't all that. Okay, this is something just to get you familiarized. Again, this is going to be in the book, and the book that's coming out is going to explain to you how to configure the routing protocols, okay, and how to work with IPv6 in the subnetting and all that. So we're looking forward, again, that's in Amazon, and it's going to be sometime in February. Hopefully the beginning of February, it'll be out there for you. But it will speak upon everything that deals with IP, especially the subnetting, summarization, VLSN, okay, and then, of course, the IPv6 and the subnetting. And yes, I put a hex in there just for fun. All right. I hope you enjoyed this HOA. More to come. I don't know how soon, but I will go ahead and do a lot more. Give me some ideas, things that you want to see that deals with the CCNA. The CCNA. Once I start doing the other certifications, then I'll do things for that. For the moment, this is my focus because everybody wants to get that new CCNA X certification. So if you have something that you still have confusions on, I'll be more than happy to make an HOA out of it, okay? All right, guys. You have a great day. I'll see you guys around.